You think the universe is basically still. Sure, planets rotate, stars rotate, galaxies rotate, but in your head that's just stuff moving, a local detail, a leftover from how it formed. That mental picture is wrong, because you don't just live in a universe where some things spin, you live in a universe where spinning is the default, where motion doesn't naturally settle into stillness, where not spinning is the special case. You imagine spin as a choice, like an object has to be given rotation, a push, a twist, a cause you can point to. But look around the cosmos. The pattern is embarrassing in how consistent it is. Dust spins into disks. Disks spin into planets. Gas spins into stars. Stars orbit in spinning galaxies. Galaxies gather into clusters with their own swirling structure. Even when things collide, when chaos should win, the aftermath is still rotation, still shear, still a preferred direction of circulation. And if you try to explain it with the picture you currently have, something must have started it. You end up with an uncomfortable question you can't answer. Started it how? If the universe began simple, why did it end up with a stubborn obsession for turning? Why does random motion keep organizing into circles instead of canceling out? Why do systems keep finding ways to spin even when you think they should stop? There's a deeper problem here. You're treating rotation like it's optional. It isn't. Spin is what remains when the universe refuses to let motion disappear. It's what you get when straight line becomes impossible because everything is interacting with everything else. It's what happens when you stop imagining space as an empty stage and start treating it like a set of constraints. You think spinning is a detail. It's not a detail. It's a signature. You were taught the wrong default, and that default is, you think stillness is normal. You think motion is something added on top of a quiet universe, a push, a kick, a disturbance that eventually fades. That's the picture you were given early, and it's stuck. Objects move because something made them move. When that influence is gone, things calm down. They rest. They stop. This feels obvious. It's also wrong. The idea that rest is the natural state comes from a very specific, very artificial experience of the world. Floors with friction, air that drags, surfaces designed to slow things down. You learned physics inside environments that aggressively erase motion, then mistook that erasure for a law of nature. But nothing in the universe is actually trying to stop. What you call slowing down is motion being forced to go somewhere else, into the floor, into the air, into vibrations you don't notice, into heat. Motion doesn't disappear. It gets redistributed until it hides in places you're not tracking. Stillness is not a baseline, it's a bookkeeping illusion. Imagine a shopping cart in an empty parking lot. You push it, it rolls. If the pavement were perfect and the air non-existent, it wouldn't gradually decide to stop. It would keep going, not because it's stubborn, because there's no rule telling it not to. Now imagine the same cart in a crowded space. People everywhere. Poles, walls, constraints. You push it forward, but it can't maintain a straight path. Every interaction bends it, deflects it, forces it to curve. Eventually, straight motion becomes impossible, not because motion is gone, but because the environment refuses to let it stay simple. This is the part you weren't taught. The universe is not empty. It is not frictionless in the way your intuition imagines. It is dense with interactions, fields, forces, other particles, other motions, and in that environment, straight-line motion is fragile. It breaks easily. When motion can't remain straight, it doesn't vanish, it curls. Think of people leaving a packed stadium. If every exit were perfectly clear, they'd walk straight out. But bottlenecks appear, paths intersect, people adjust, they arc around one another. Small detours compound. Suddenly the crowd forms circulating patterns, not because anyone planned it, because straight paths stopped being available. You look at a spinning planet and think, something must have twisted it. That assumption comes from believing that rotation is a deviation from normal behavior. It isn't. Rotation is what motion becomes when stillness is forbidden and straight lines are unsustainable. It's the compromise motion makes with a crowded universe. This is the uncomfortable shift. Motion is primary, rest is negotiated, and spin is what's left when negotiation fails. You were taught that calm comes first and movement is a disruption. In reality, it's the other way around. Straight lines are a privilege. You imagine motion as wanting to go straight. You picture a universe where, unless something interferes, objects trace clean lines through space. Curves feel like violations, detours, evidence that a force stepped in and bent the path. That picture only works in a universe that almost never exists. Straight line motion requires something extremely rare: isolation, no nearby masses pulling, no fields tugging, no uneven distributions, no background structure, no history. The real universe doesn't offer this. A straight path is not the default. It's a luxury granted only when nothing else is around to care. Try walking straight through a dense crowd. Not metaphorically, actually try it. At first, you move forward. Then someone crosses your path. You adjust. Another person forces a step sideways. You compensate again. Each correction is small, reasonable, local. But after enough of them, your path isn't straight anymore. It curves, it loops, it bends around invisible centers formed by other people's motion. No one pushed you into a circle. The environment removed the option of a straight line. This is how motion behaves in a universe full of interactions. Every particle, every clump of matter, every field creates a slight preference, a tug, a bias. None of them are dramatic alone. Together, they make straightness unstable. You're used to hearing that forces cause curves. That phrasing hides the deeper truth. Curves happen because maintaining straightness requires perfect cancellation of all influences. And perfection is fragile. Even light, the closest thing the universe has to pure straight motion, bends. Not because it's weak, because space itself isn't neutral. Mass reshapes the available paths, and light simply follows what's left. A boat trying to cross a calm lake can go straight, add slow, uneven currents beneath the surface, and the boat still tries to go forward, but its wake tells a different story. From above, the path arcs. The motion didn't change intention. The environment changed the geometry. On cosmic scales, there are no calm lakes. Gas clouds don't drift peacefully. They feel gradients in pressure, gravity, radiation. Slight imbalances amplify. Paths bend toward denser regions. Miss by a little, and the miss becomes a loop. Miss again, and the loop tightens. This is where your intuition fails. You expect interference to cancel motion, but interference usually redirects it. When every straight option is blocked by interaction, motion doesn't stop. It circulates, it finds closed paths, it repeats. Rotation is not an added feature. It's the geometric consequence of trying to move in a space where nothing is truly empty. Once you see that, the spinning universe stops looking excessive. It looks inevitable. Why motion refuses to die? You expect motion to run out, not suddenly, gradually, like a battery draining, like sound fading into silence, like a thrown ball losing its ambition and settling back into the ground. That expectation feels reasonable because, in your daily life, motion is constantly disappearing. Except it isn't. It's being hidden. Every time something slows down, you're watching motion change form. The rolling ball transfers its movement into the floor as tiny vibrations. The sound doesn't vanish, it spreads into the walls, the air, the microscopic shaking of atoms. You stop noticing it long before the universe stops accounting for it. The universe is obsessive about bookkeeping. It does not forget motion. It does not forgive losses. It only allows transfers. Imagine money in a closed economy. You can move it between accounts. You can break large sums into many small ones. You can hide it in obscure places. But you can't make it vanish without breaking the system itself. If you think it's gone, it's because you stopped checking the right accounts. Motion works the same way. Now imagine that you remove all the easy places to hide it. No rough surfaces, no air, no external environment to dump energy into, no outside to absorb the mess. What happens then? Motion has to stay inside the system. At first it moves as translation, objects drifting, particles flying. But translation is easy to disrupt. A collision here, a deflection there. Straight paths fragment quickly in a crowded universe. So motion looks for something more robust, something that survives interference. Rotation does. If two objects collide off-center, their forward motion doesn't disappear. It reappears as spin. If a cloud collapses unevenly, its inward motion doesn't cancel. It converts into circulation around a center that didn't exist before. This is not a coincidence. It's a survival strategy. Think of kids trapped inside a small room, told they're not allowed to throw a ball out. At first, they toss it back and forth. Eventually, it becomes chaotic. Someone drops it, someone bumps into someone else. Straight throws stop working, so they adapt. They pass in a circle. The ball keeps moving, even though the rules tightened. Rotation is motion obeying constraints. This is why spinning shows up everywhere, not because the universe loves circles, but because circles are hard to destroy. They don't need a destination. They don't require an exit. They reuse their own path. When motion can't escape and can't remain straight, it does the only thing left. It loops. You think motion dies because you watch it leave the forms you recognize. The universe thinks motion survives because it never left at all. Collapse does not mean stillness. You hear the word collapse and you imagine calm. You picture things falling inward, canceling their motion, settling into something quiet and compact, like dust sinking to the bottom of a room, like chaos resolving into rest. That image is deeply misleading. In the universe, collapse is not a path to stillness. It is a machine for amplifying motion. When a system shrinks, it doesn't lose its movement. It concentrates it. You've seen this, but you treat it like a trick instead of a rule. A figure skater spins slowly with arms extended. Then they pull their arms in. Nothing new is added, no extra push, yet the spin accelerates, violently. The same motion, forced into a smaller space, becomes faster, sharper, harder to ignore. This is not a special human trick. It's what happens whenever motion is conserved but space is taken away. A collapsing gas cloud is a skater pulling in its arms. At first the cloud is enormous. Any tiny sideways drift seems irrelevant, a random nudge, a meaningless imperfection. But as gravity pulls everything inward, that imperfection has nowhere to go. The cloud shrinks, distances shorten, paths curve tighter. What was once negligible becomes dominant. You might think opposing motions would cancel during collapse, that inward streams would collide and neutralize each other. But cancellation requires perfect symmetry, and collapse destroys symmetry faster than it creates it. No region falls in at exactly the same rate. No particle arrives at the center from the same direction at the same time as its opposite twin. Small differences amplify. Misses become orbits. Orbits tighten. Rotation emerges not despite collapse, but because of it. Water draining from a sink doesn't form a spiral because it wants to. It spirals because straight down becomes impossible once the basin geometry and tiny imperfections matter. The drain doesn't calm the water, it organizes its motion into a rotating structure that survives the fall. Cosmic collapse works the same way. Stars spin because the clouds that formed them had no way to erase their slight sideways motion as they shrank. Planets spin because the disks they condensed from had already folded motion into rotation. Galaxies spin because collapse on massive scales doesn't average things out, it sharpens them. This is the inversion you weren't prepared for. Compression doesn't eliminate motion, it weaponizes it. The smaller the system becomes, the louder rotation gets. Collapse is not the universe sighing into rest, it is the universe shouting motion into tighter and tighter loops. and once rotation is there, it becomes very hard to remove. Why randomness creates order that spins. You expect randomness to neutralize itself. In your mind, disorder is a mess of directions that should cancel out. One motion goes left, another goes right, and on average, nothing survives. Randomness feels like a solvent. Add enough of it, and structure should dissolve. That intuition fails quietly but completely. Random motion does not prefer stillness, it prefers circulation. Imagine a crowded train platform where everyone is pacing while waiting. No coordination, no plan. People drift, turn, hesitate. At first glance, it's chaos, but watch long enough and patterns emerge. Lanes form, loops appear around obstacles. People start moving in circulating paths without realizing it. No one decided to organize. Constraints did. Randomness alone doesn't build order. Randomness under constraint does. And the universe is nothing if not constrained by geometry, by conservation, by the impossibility of motion simply vanishing. When many random motions share the same space, direct opposition is rare. Perfect cancellation requires two motions of equal size, opposite direction, and precise timing. Randomness almost never offers that. What it offers instead are near misses. Near misses don't cancel, they deflect. Multiply enough deflections and you don't get silence, you get swirl. This is why weather systems spin. Air molecules don't agree to form hurricanes. They move randomly in a temperature gradient, constrained by a rotating planet and uneven heating. Random motion collides with boundaries and gradients, and rotation becomes statistically favored, not because it's designed, but because it's stable. Traffic behaves the same way. Cars enter a busy intersection from many directions, unpredictably. If there are no rules, chaos follows, until drivers invent them. Roundabouts appear not because they're elegant, but because they prevent deadlocks. Circulation beats cancellation. The universe learned this long before roads existed. In a collapsing cloud, countless particles move randomly. Most of that randomness doesn't disappear. It gets sorted. Radial motion, straight in or out, is fragile. It collides. It shocks. It dissipates into heat or deflection. Tangential motion, sideways drift, survives. It avoids head-on collisions. It wraps around. Over time, what remains is rotation. This is not an accident, it's a filter. Randomness feeds many forms of motion into a system. Constraints quietly kill the ones that self-destruct and preserve the ones that don't. Spin is the survivor. You look at rotating disks and think they're signs of order imposed on chaos. They're the opposite. They are chaos that learned how not to die. The universe has no brake pedal. You keep waiting for spin to end. It feels reasonable. In your experience, everything rotating eventually slows. Tops wobble, wheels grind down, fans power off, motion decays. Time, you think, is a universal brake. That belief only holds in rooms full of friction. Rotation doesn't stop because time passes. It stops because motion leaks into an environment that can absorb it, and on cosmic scales, that environment mostly doesn't exist. A wheel slows because the ground steals its motion. Air steals a little more. Heat carries it away into countless microscopic vibrations. The wheel isn't tired, it's being robbed. Now remove the thieves. Put the same wheel in deep space, no air, no ground, no surface roughness, no external sink, nothing to take the motion. What happens? It keeps spinning, not for a long time, not for an impressively long time, indefinitely. The universe does not come with a built-in braking system. Brakes are local inventions. They are consequences of interactions with something larger. And when there is nothing larger, nothing outside the system, there is nowhere for rotation to go. You're used to thinking of friction as fundamental. It isn't. It's emergent. It requires complexity, contact, asymmetry. On large scales, the universe is too clean, too empty, too indifferent to provide it efficiently. Stars spin for billions of years, not because they're perfectly smooth, but because there's nothing big enough to slow them down. Planets keep rotating long after their formation violence ends. Even galaxies, vast, chaotic, collision-ridden systems, retain coherent spin across timescales that dwarf civilizations. You might object, collisions should stop them. Collisions don't remove rotation, they redistribute it. When two spinning systems interact, their rotations don't vanish, they couple, they trade angular motion, they shear. They form larger rotating structures or smaller ones. Motion spreads, but it does not break. This is the quiet truth. The universe is very good at moving motion around, and very bad at destroying it. You thought time smooths things out. Time only exposes whether there's an exit. And for spin, the universe rarely provides one. Rotation persists not because it's stubborn, but because it has nowhere else to go. Spin is the shape of persistence. By now, rotation should feel less like a feature and more like a consequence, not something added, not something chosen, something that remains. This is where the intuition finally breaks. You've been treating spin as behavior, as mechanics, as objects doing something in space, but that framing is too small. Spin isn't just motion. It's memory. A rotating system is a system that remembers its past. When motion can escape, history gets erased, a sound fades, a ripple smooths out, a push dissipates into a larger world that forgets it ever happened. But when motion is trapped, when there is no outside to absorb it, the past has to go somewhere, so it folds. A straight path forgets where it's been, a loop does not. A loop retraces itself. It revisits the same locations, the same orientations, the same relationships. Rotation is motion that refuses to let go of its own history. This is why spinning structures are everywhere. They are the universe's way of storing motion when erasure is forbidden. Think of a whirlpool in a river. Water flows in, water flows out, but the structure persists. Not because the water is special, but because the pattern is stable. The whirlpool isn't a thing. It's a behavior that survives replacement, a memory written into flow. Galaxies are like that. Stars come and go. Gas clouds collapse and disperse. Entire regions rearrange. Yet the rotation remains. The spin outlives its components. It carries information forward in time, long after the original causes are gone. This is unsettling if you're attached to the idea of a forgetful universe, because it suggests that motion doesn't just happen and disappear. It accumulates, it gets encoded, it leaves scars. Spin is one of those scars. You thought the universe was trying to settle down, to relax into stillness, to forget its violent beginning. It isn't. It's conserving it. Every rotating object is a fossil of motion that couldn't be erased. Every orbit, every disk, every spiral is the universe admitting that something happened, and that it never found a way to undo it. Stillness then is not peace, it's amnesia, and the universe is very bad at forgetting. So when you look out and see everything turning, planets, stars, galaxies, clusters, you're not seeing excess motion, you're seeing persistence. You're seeing history wrapped into geometry. Spin is not what things do. Spin is what remains when the universe remembers.